Here is the fast solution followed by an elaboration and two different approaches to the question. If the largest of the items is 13, then the smaller distinct item is 12. 13 and 12 add 3 and 2 respectively to the average of 10. The least possible value must be 5 less than the average of 10. 10 minus 5 equals 5. B. Slightly slower, remember that the sum of differences from the average is always 0. This is especially useful when the average is given, as was the case here. If we indicate an average of 10, then we can see that 13 adds 3 to it. Since we wish to find the least possible value of the smallest of the three integers, we need to increase the middle integer as much as possible. The 13 is fixed and cannot be altered. Can that middle integer be 13 as well? The answer is no, since we were told that the integers are distinct. The next largest integer is 12. We can see that given an average of 10, 13 pulls up by 3 and 12 pulls up by 2. Together, 13 and 12 pull up by 3 plus 2, so by 5. Since we know that the sum of differences from the average is always 0, the least possible item will have to correct this addition of plus 5 by subtracting 5 from the average. What number is 5 below the average of 10? 5. The correct answer choice is B. Another worthwhile approach when coming across questions which ask us which is the least value is to simply plug in the least number from the answer choices. If the least number is 4, then the sum of the three distinct integers is 4 plus m for the middle-sized number plus 13 divided by 3 equals 10. 17 plus m equals 30. M equals 13. Can m be 13? The answer is no, since again we were told that the items must be distinct. At this point, it is quite clear that the correct answer choice is most likely B, but let's prove it. If the least number is 5, then the sum of the three distinct integers is 5 plus m plus 13 divided by 3 equals 10. 18 plus m equals 30, m equals 12. Can m equal 12? There's no reason why it shouldn't. What's beautiful about this takeaway is that other than solving relatively challenging questions, we didn't have to think too hard about the logic behind the question. Finally, now that we've explained the rationale, we can also solve this question mathematically, even though usually that solution will not be as quick. Mind you, this mathematical solution still requires that we understand that in order to decrease the smallest number as much as possible, we have to increase the medium number as much as possible to 12. If the least integer is x, the second largest integer is 12, and the largest integer is 13, then their average must yield 10. X plus 12 plus 13 divided by 3 is 10. Always simplify. X plus 25 equals 30. X equals 30 minus 25. X equals 5. Even though we saw three different solutions to the same question, by far the most recommended one is this first one, since unlike the other two solutions, it allowed us to actually understand the quantitative logic behind the question. This understanding is priceless when similar questions start dealing with variables rather than with relatively simple integers. Please review this video before taking the test.